Hello, good morning, and welcome back to my YouTube channel. It's still the online science tutor. I'm Ogenetica Caroline, a graduate of Petroleum Engineering Technology from the Petroleum Training Institute. Alright, for those that have subscribed to this channel, I want to say a very big thank you. We're most grateful. We don't take it for granted. Thank you so much. And for those that have recommended us to their friends, we want to say a very big thank you. Alright, so we started this channel because of a strong desire to help our secondary school students of African origin, especially with the basics of science and those that have to do with calculations. Because over time, I'm into the academic world, and so I've come across different students that I prepare for their senior secondary certificate examinations, and I discovered that most science students lack a basic grip on the basic concept in sciences that they should actually be able to conveniently do, especially those that are female. Okay, and so that became a burden, and we decided to start up this channel to address some basic things that science students find issues with at secondary school level. Okay, so we treat different subjects in this channel. So there are days we treat calculations that revolves around chemistry, physics, and then sometimes mathematics, and most recently we are also discovering that most science students we're also discovering that most science students have a basic challenge with use of English, and so we are having to include that, because we also discovered as well also that most science students that desire to study medicine and some other subjects, medicine and some other related courses, do not have a firm grasp of the use of English, and it's also a subject that they compulsorily need to make very good grades in. And why not add English language to it? So yeah, sometimes we also do some basic English language operations, like oppositing meaning, bringing up new words, and what best fits a sentence. Alright, so having said that, this morning we are going to be taking this our lecture today is going to be on chemistry, and an aspect of chemistry that is very interesting. Yeah, and an aspect of chemistry also that is fundamental to most of the sciences you're going to do. Okay, so we're going to be doing some calculations this morning. Calculation of a percentage by mass of a particular element that can be in a compound. Okay, but for us to conveniently do that, we need to know various elements, most especially the first 20 elements, and then we need to know their mass number as well as their atomic number. Okay, so without much ado, I want to write out the first 20 elements, but then I also discovered from closely working with students over the years that most science students don't even know their first 20 elements by heart. And so if I stand in this place right now and I'm telling you that okay, your first 20 elements is hydrogen, helium, lithium, beryllium, boron, carbon, some of them are going to be saying, okay, I know, I have done this in SS1 at senior secondary school certificate level 1. I've done this in my SS1 class, but is there a formula I can conveniently remember that anytime I want to write out the first 20 elements, just like an acronym that I can easily recall, and I'll be able to bring out my first 20 elements conveniently? So because of that, there is a formula that we derived. It's kind of playful, yeah, actually, at SS1 level, that we normally use to remember and easily write out the first 20 elements. So I'm going to say the formula and write out the first 20 elements from it, so that is something you can always go back to and not be stuck in thinking about, oh, how do I know my first 20 element? So the formula is, it may sound funny, yeah, it may sound funny, but please, the whole idea is to be able to remember the first 20 elements without so much work, okay? Alright, so the formula is E has large brain but can not offer few 9 subjects. May all silly people stop calling a puppy cat. Okay, so that's the formula. We just derived this at when I was still in secondary school anyway, to be able to conveniently remember our first 20 elements. So we just generally, jovially and jokingly just say that he has large brain but cannot offer few 9 subjects. May all silly people stop calling a puppy cat. Alright, and the reason why we had to do that, especially the part of using that he cannot offer few 9 subjects, is because at then, when I was in secondary school, at WAEC level, students offer 9 subjects for their WAEC exams. So just say it jokingly, he has large brain but cannot offer few 9 subjects. May all silly people stop calling a puppy cat. Alright, so having said that, the whole idea is that the first alphabet of what you are using as the acronym is going to be replaced by the element. So for he has now, he, hydrogen, has, helium, large, lithium, brain, beryllium, but, boron, can, carbon, not, nitrogen, offer, oxygen, few, fluorine, 9, neon, subject, sulphur, may, magnesium, all, aluminium, silly, silicone, people, phosphorus, stop, sulphur, chlorine, chlorine, A, argon, puppy, potassium, and cat, calcium. Okay, so each alphabet, the first word of each of the alphabets in the series is capitalized so that it can replace the particular element that should be there. Alright, so we have E, so this gives me hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicone, phosphorus, sulphur, chlorine, argon, potassium, and finally calcium. Okay, so you see how easy it becomes to write out my first 20 elements without really making any error, because my formula is guiding me. So whenever I say he has large brain but cannot offer few ninth subjects, may all silly people stop calling a puppy cat. So whenever I do that, the first word, the first alphabet of every letter in the sentence structure is capitalized. So that's what's telling me which element should be here. Is it N? Is it S? Is it M? So that's really the basic idea. Alright, so have you been able to design a way that we can conveniently write out our first 20 elements without forgetting any of the elements and without misplacing them? We're going to go into knowing the mass number of a particular element and the atomic number of that element. So I'm going to be writing the atomic number, and then the mass number. So ideally, so this is not something that it's a rule, but ideally the atomic number simply goes the way it's just serial. So that means that the atomic number goes exactly with the numbering you already have. So hydrogen is 1, helium is 2, lithium is 3, beryllium is 4, boron is 5, just like that in a very serial order. That conveniently gives you your atomic number. And don't forget, the atomic number of a substance or an element is the number of protons contained in its atom. The number of protons that is contained in an element is known as the atomic number. So anytime you are talking about atomic number, you're talking about how many protons are present in that particular element. But the mass number is the number of protons and neutrons. So it's a summation of the number of protons and neutrons that are present in the atom of a particular element. For most elements, I have discovered that their mass number tends to be like times 2 of the atomic number. That's not a rule. That's why I said for most. It's not for all. There are so many exceptions to that rule. But then, if you are able to know the atomic number, you should be able to know the mass number. You just need to study them in the periodic table. Okay, so those are also values that you can easily, conveniently put in your brain. Yeah, you're a science student actually. Okay, alright, so for the atomic number, I already said it follows a serial. So hydrogen is 1, the 2. So you see that for the atomic number, they follow serially as the position of that element in the periodic table. So we just see hydrogen is having atomic number of 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, sodium 11, magnesium 12, aluminum 13, silicone 14, phosphorus 15, sulphur 16, chlorine 17, argon 18, potassium 19, and calcium 20. Alright, but for the mass number, I'll most preferably advocate and advise that you get that from the periodic table, because oftentimes it's not, you need to know the number of neutrons that are present in that compound, and it's not always that the number of neutrons is equal to the number of proton. For those cases where the number of neutrons is equal to the number of proton, you just discover that the mass number is going to be times 2 of the atomic number. This is where the atoms that are present in a particular element, let's say the neutrons are more than the proton by 1, you are going to see that that rule of just multiplying by 2 is not going to work. Okay, so so I cannot tell you that this is just what you should do, just multiply by 2. No. But for elements like calcium, it's 40, it's 39, 35.5, sulphur is 32, so for the mass number, you should be able to conveniently get it from your periodic table. Okay, alright, so we actually said that our emphasis today is going to be on calculation of percentage by mass of an element present in the substance. So that's what we're going to do next. Already established that the atomic number of an element is the number of protons that it contains, while the mass number is an addition of the proton and the neutron it contains. So for hydrogen now, you can easily deduce that hydrogen contains 1 proton and 0 neutron. That's why 1 plus 0 equals 1. While for helium atom has 2 protons and 2 neutrons, so 2 plus 2 equals 4. Lithium possesses 3 proton and 4 neutrons, so 3 plus 4 equals 7. Hope you understand. So anytime you're looking for the mass number of a particular element, all you need to do is just do a summation. That's, you add up the number of proton it has and the number of neutron it has. That will give you your mass number. So we said we are going to be doing calculations that relates to the percentage by mass that every element has in a particular compound. To do that, what we'll be using is the mass number of the element, not the atomic number, which was why I advocated earlier that if you are not so familiar with the mass number of each of the elements, especially for the first 20 elements, please go to your periodic table and try to get it into your brain, okay? Because it's not every particular element that has that you just multiply the atomic number by 2 to get the mass number. Some are not like that. For example, you see, sodium is 23, that is has a mass number of 23. If we were always saying that we should just multiply by 2, 11 times 2 will give us 22, not 23. Even aluminium has that same challenge also. So you see, aluminium has 14 neutrons instead of 13, and so many others like that. So please check through the periodic table and try to get it in your brain, okay? Alright, so anytime we're calculating for the percentage by mass of an element in a compound, we are trying to get how much of that element makes up one molecule of that compound, okay? So if, for example, I'm calculating the percentage by mass of sodium in sodium chloride, I'm looking at how much of sodium is needed to make up 1 mole of sodium chloride. So in doing that, I will need to know the mass number of sodium first, and I need to know the mass number of the compound itself. It's more like a probability. If anytime you are asked to do the probability to find out, for example, the percentage of male to female in a class, you know you are going to find out the total number of students present in that particular class before you find out the amount of guys to girls. Okay, all right. So having established that, for percentage by mass, we're going to find out the mass of the compound itself first. That's 1 mole of the compound, and then we can find out the various composition, their constituents. And in doing that, please take note that it's not just, you are going to need the correct formula of that compound. Okay, so you need to get the exact formula of that compound to be able to solve for the percentage by mass in that compound. And then you are going to need to solve based on how many of that particular element is present in the compound. When we start solving, you'll see all of these things play out. The question says, what is the percentage by mass of sulfur in aluminum tetraoxosulfate 6? If you see the formula, the first thing I want you to do is to write out the constituents, each of the constituents that make up the particular formula you are looking at. Okay, so if you do that, you will be able to know what you are going to be solving with, and then we can easily look for the relative molecular mass. So first thing first, we have aluminum in this compound, we have sulfur, and we have oxygen. Okay, but then you come back and look at the formula you are given again. You see that there is 2 molecules of aluminum here, so whatever I'm going to do to aluminum is going to be times 2. And then for sulfur, mathematical knowledge is required here also. So you see that this 3 is enclosing this bracket, so I'm going to use this 3 to open up this bracket. So if I use 3 to open up this bracket, that's going to give me 3 times anything I have for sulfur, and then 3 times 4, 12. 12 times whatever I'm going to have for oxygen. The next thing I'm going to do is to now take their mass number and solve. Okay, so for aluminium, we know that the mass number of aluminium is 27, the mass number of sulfur is 32, and the mass number of oxygen is 16. So you do that. If you do that, the summation should give you summation should give 342 gram per mole. So that means that this particular compound is made up of 342 gram per mole. Now the next thing I was asked to do is to look for the percentage composition of sulfur in this particular compound. So I'm going to take whatever sulfur has, the same way you solve for your probability in maths. So it becomes amount of substance, amount of sulfur now, over the total mass times 100%. Since I'm looking for percentage composition, and this will give us 28.07%. Okay, so I decided for us to use this particular example because it's going to illustrate everything I'm going to be saying that are actually key points. And that is the fact that, one, you need to know the mass number of each of the constituents first that you're working with. So you need to know the mass number of aluminum, that it's 27. You need to know the mass number of sulfur to be 32, and then you need to know the mass number of oxygen to be 16. So that's why that table I was telling you about, the mass number and the atomic number, is very critical. Okay, it's important. So after knowing that, you need to also be able to get the exact formula, the correct formula. For example, if you are looking for the percentage composition of sodium in sodium chloride, and you write your formula as NaCl2, you are going to be wrong because this is not the correct formula for sodium chloride. If you are given just the name, you need to be able to write the correct formula out, and then you write each of the constituents out, and then ensure that you get the exact composition of that particular element in the constituent. So you need to know that this 3 is affecting everything in between the brackets. So be able to know that sulfur is 3. It's 3 times the mass number of sulfur that you're going to work with. If you don't do that and you just decide to solve and say aluminium is 1, use only 1 to multiply aluminium, and then you use say 1 to multiply sulfur, everything you are going to get is going to be wrong. Okay, all right. So if you are given just the name, you need to be able to write the correct formula out, and then you write each of the constituents out, and then ensure that you get the exact composition of that particular element in the constituent. So you need to know that this 3 is affecting everything in between the brackets. So be able to know that sulfur is 3. It's 3 times the mass number of sulfur that you're going to work with. If you don't do that and you just decide to solve and say aluminium is 1, use only 1 to multiply aluminium, and then you use say 1 to multiply sulfur, everything you are going to get is going to be wrong. Okay, all right. So how have you been able to get value today? And if you have any question, please drop them in the comment section below. And please do like this channel, subscribe to this channel, and tell your friends about it. Would be glad to have them on board as well. Do have a very wonderful day. It's still the online science tutor. Have a blessed day.